In this particular question, assertion, the energy of a charged particle moving in a magnetic field do not change. So assume that this is a magnetic field, uniform magnetic field, and this uniform magnetic field is directed inward. Magnetic field is B, and suppose assume that there is a charged particle which entered this uniform magnetic field with some velocity V. So due to this, what will happen? As this is V is towards right, B is into the plane. Then according to Fleming's left-hand rule, what will be the direction of force? Direction of force will be upward. So that means that force should be perpendicular to both V and B. So due to which, what will happen is that due to that force is perpendicular to the component that perpendicular to velocity, and here as it starts as the charge particle starts entering the magnetic field, so it will experience the force. So it will start moving. Initially it was moving towards right, and due to this force it will start moving away from its original path. So it will move like this. So at this point also, what you can say, if the direction of velocity will be tangential to the path, that means the displacement will be along the direction of velocity. So elementary displacement, if we consider any kind of elementary displacement, for any kind of elementary displacement, that displacement is generally here tangential to the path. Here the displacement is tangential to the path. So as the charge particle will undergo some sort of semicircular path, and after that it will exit from the field over here. uh, then for any kind of elementary displacement, the force will be what you can say, it is perpendicular to that one. So if the force is perpendicular, that means according to Fleming's left hand rule, the force is perpendicular to both V and B, and that then here in this particular case, then what done will be equal to F dot S. For any kind of small elementary displacement, it will be equal to F dot S, and finally it will be F ds cos 90 degree here. So it will be 0, no work done. So if that's the reason is saying is that it is because work done by the magnetic force on the charge moving in a magnetic field is 0. So magnetic force will do what is the work done by magnetic force, it will be simply 0. So this is the reason why the energy of a charged particle moving in a magnetic field do not change. Clear? This is the reason why the energy with which the charged particle enter this magnetic field, it will come out of this magnetic field with same energy. The charged particle charged particle uh, will come out or you can say will exit the magnetic field with the same energy, as it was having while entering, so here in this particular case, both assertion is true and region also true, and region is the correct explanation of assertion. So option A will be the correct one.